variables change, whether they're talking about profit or final population or anything of that nature, where they will give you the formula and they'll tell you what everything stands for. This one's just a lot more complex, and this came up. It's not hard, it's just long, so it seems very intimidating, I think. So a monthly mortgage payment can be found using this formula. So M is your monthly payment, capital P is the amount that you borrowed from the bank, R is your annual interest rate as a decimal, N is your number of monthly payments. So we'll just read through probably 500 times before we kind of wrap our heads around what's going on and what numbers go in for what variables. So the bank's family would like to borrow $120,000. Where is that going? P, amount borrowed, $120,000. They qualified for an annual interest rate of 4.8%. What do we do with that? R, so R equals what? 0.048, very good. Algebraically determine the fewest number of whole years. So, what are they asking us for? What'd you say? N, kind of. Our formula is going to tell us the number of monthly payments we have to make. We're going to have to convert that into years. Yes? So this is still our variable. It's not going to be our answer, but it's going to lead us almost directly to our answers when we try to figure out how many monthly payments that turns into how many years. And then what they need to include in the mortgage agreement in order to have a monthly payment of no more than $720. And the $720 is going to go in for your monthly payment. So we're going to treat this like, if we make a payment of $720, how long will this take us? And then we'll answer it from there. So, capital M is 720. And then there's this big fraction with fractions within the fraction, so make sure you're writing this very clearly. Capital P is your 120,000. R is 0.048 over 12. And then you have another 1 plus 0.048 over 12 to the nth power. And then on your denominator, you have 1 plus your 0.048 over 12 to the nth power again, minus 1. So a couple things that you can, what could you simplify just to not start solving anything yet, but just to kind of pare this down, Haley? The 0.048 over 12, which shows up 3 times, is 0.004. So this, and this is 0.004. So 720 equals 120,000. 0.004. This, by the way, can I just make it 1.004? Handle the 1 plus at the same time? Do you follow that? Same thing down here, 1.004 to the nth power minus 1. Okay, then one other thing I can do quickly before I start solving. Chloe. Right, this times this. I can't multiply this one in yet because it has an exponent attached to it, but these two, the 0.004 times 120,000 just gives me 480. So I get 720 equals 480 times 1.004 to the nth power over 1.004 to the nth power minus 1. So this part is where it gets to be new solving to. And this is why I decided this was one problem. This is why I decided I was just going to take another day on it, just in case this ever comes up. The reason this is new, looking from here, is because you've got your exponent, 1.004 to the nth power, in 2 different spots. one of which is in a denominator. So the first thing we need to do is get that out of the denominator. So I'm almost just going to like cross multiply. So when I multiply 720 times this binomial, I have to distribute. 720 times this first term, though, I can't actually do 720 times 1.004 because there's an exponent attached to that 1.004. So I just have to be comfortable leaving that 720 times 1.004 to the nth power alone. And then I can distribute the 720 to the -1 and just make it minus 720. So that's distributing. And then on the other cross multiply, I'm just multiplying by 1, so I'm not really changing anything. So far, so good? So still I've got these 1.004s to the nth power in two different locations. If those bases were different, I would not be able to do this algebraically. I would just type it into my calculator. Left side as one equation, right side as another, see where they cross. But because they are the same base to the power, I can kind of combine like terms. I have 720 of them on the left and 480 of them on the right. I can subtract these 720 of them over to the right. So subtract 720 of these things. And 480 of them minus 720 of them leaves me with negative 240 of them. So in a way it was combining like terms, but a little more convoluted than it normally looks. Like 480x minus 720x would have been a heck of a lot easier to recognize. So once you recognize that, oh, it's the same thing on both sides, and we have a 720 over here and 480 over here, let's just consolidate these and get them all together. Now solving this is pretty much reinforcement. Divide your negative 240 over. Now negative 720 divided by negative 240 is a nice whole number, 3. So that ends up being 3 equals 1.004 to the nth power. Jason, what would I do next? Log both sides because that variable's in an exponent. Good, so log and log. And so log of 3 equals, and I'll bring this exponent out in front, n times the log of 1.004. And then Jack B to get that all by itself. To get n all by itself. Add it? No. Divide it, because it's n times. Good. Divide log 1.004. Log of 3 divided by the log of 1.004. 275.2, let's say. So if I was making exactly, and we have to go back and remember, okay, what was the context and what was going on here? If I was making exactly a $720 a month payment, it would take me that many monthly payments, so essentially that many months to pay off my loan, right? Which they want to know what is the least number of whole years. So here's the thing. I have to make 275 payments for sure, and then like almost like a partial one, right? Even though this is one of those cases that even though the nearest whole number of months is 275, you can't round down because you'd be short money. You might only be short 50 cents from a $120,000 loan, and you think, well, why would they even care about that? But you can't be short. So you have to make 276 monthly payments. And then we're going to convert that into years. So how do you take 276 months and turn it into years? divide by 12, and you're going to get 23 years. Which is about the amount of time it, like housing loans are, 20 to 30 years, 15 to 30. Good? Any questions on that? Now, by the way, your monthly payment was $720, and you're doing that for 12 months for 23 years. This is just more of a, do you understand how this whole thing works? You're making $720 payments times 12, so that would be your yearly payment times 23 years, and you're paying $198,720. How is that possible if you only borrowed $120? Why did that happen? Interest, right. So you're paying the $120,000 for the house, but you're paying an additional $78,720 to the bank for the luxury of them loaning you the money. And that's just how it works. Haley.
There's a question like this on one project, and like you like payments instead of like doing like 276, you did 275, would you get it wrong?
It's probably like a 4 to 6 point question. We hate grading questions like this for that reason. No, you wouldn't. We would work through where you made your mistake, and if it pans out with the answer you got, then you would get it right. But we sort of like look and like try to find how many mistakes did you make. If we find like 3 mistakes, then it's over. But if you just make one and it totally throws your answer, that's why we always say, even though you know the answer doesn't sound right, don't erase your work and leave nothing. Because even though it might not make, the answer doesn't even make any sense, and you can't find your mistake, we can find it, and we can base that answer off of that and still give you 5 out of 6 points or 3 out of 4, whatever it is. Okie doke. Oh, so lengthy. It's a long equation. We'll just get this one set up. So they throw a totally different looking, not totally, we can draw some comparisons, but a very different looking formula at you in this problem. But again, they'll outline what everything stands for. A mortgage payment is M, so M is your mortgage payment. P is your principal amount of your loan, that's how much you borrowed. R is your monthly interest rate again. N is the number of monthly payments, and that covers everything. So, Jim is looking to buy a vacation home for $172,600. Where does that go? P. And then they tell us about the formula. Jim's bank offers a monthly interest rate of 0.305%. So where does that go? R, except for that's your percentage, you need to write it as a decimal, which is weird because it's already a decimal, but that would be 0.00305. A 15-year mortgage. What does that tell you? Yeah. Well, N is the number of monthly payments, but it ties in with N. Right, 15 years times 12 months would be 180 monthly payments. So N equals 180 monthly payments. Okay? With no down payment, that means the house is $172,600. He's borrowing exactly that. One thing about down payments is if you made a $10,000, because they've added in these stipulations too, if the house you want to buy costs that much, but you're planning on making a $10,000 down payment, how much are you really loaning? If they added that sentence, here's the cost of the home, but you're making a down payment of $10,000. What P would you then use? What's the amount that you actually have to borrow? What do you think, Lucas? $162,600, right? Your down payment is what you have already, and you're not borrowing that money, you're just paying that. What you're borrowing is kind of what's left over. So if they add in that down payment idea, that's how you would handle that. So this one says with no down payment, so we're going to keep P 172,600. And then we would plug in all those things and solve it. And on that one, we're going to be solving for the mortgage payment P. So that one's going to be a lot easier. We have all these numbers. We're just going to crunch all those numbers and divide by that on both sides, and P will already be by itself. The solving of that would be much easier. So your homework is just the back 3 questions. 1, 2, and 3 on the back.